how can we tell if a chemical reaction has occurred? Well, it would be great if we could zoom in. I don't know, did any of you guys watch The Magic School Bus? Yeah. Awesome, right? So wouldn't it be cool if we could get on the Magic School Bus and shrink to the size of molecules and actually see what's happening? That would be awesome, but we can't. So we have to find other ways to identify when a chemical reaction is occurring. If we could zoom in, we would see that atoms are going to combine with other atoms to form compounds, that if we're starting with molecules, those beginning molecules decompose, new molecules form, atoms in one molecule change places with atoms in another. It's a lot like taking some little Lego figures and taking them apart and putting them back together in different ways. But we can't zoom in on that and see it. So there are some things that we can detect with our five senses to indicate that a chemical reaction may have occurred. Color change. Here's an example of a children's spoon. When you put this spoon that's coated with this plastic coating into water that's too warm for the baby's mouth, the color will change, indicating that you shouldn't feed your baby that food yet because it's too hot. Okay? That's a chemical change that occurs within the molecules coloring that plastic coating. So a color change can indicate a chemical reaction. When a solid forms where there was not a solid before, here we have this, it's a yellow liquid, but it's very clear. And we mix that with this colorless clear liquid, it looks like water, and this cloudy reddish brown stuff forms. And if you let that sit, it'll all settle to the bottom, and that's actually a solid. That's a solid that forms where there was no solid before. It's evidence of a chemical reaction. Formation of a gas. Plop, plop, fizz, fizz. Oh, what a relief it is, right? Drop an Alka-Seltzer into water and it fizzes. Why does it suddenly make gas bubbles form like that? It's a chemical reaction occurring. The ingredients in the Alka-Seltzer tablet are reacting with the water and they're forming new substances. One of those new substances is the gas that's being formed. Heat and light being absorbed or emitted are also evidence of a chemical reaction. So this is a photograph of a natural gas burner. So we see the flame, so light is being given off, and we know from experience that that's also going to be very hot, right? So that's evidence that there's a chemical reaction occurring. You can buy these instant cold packs. They're sitting around at room temperature, and you mash them up and you break a little seal inside and squish them around and they get cold all by themselves, right? It's magic. You know, it's chemistry. It's a chemical reaction. Why is it getting cold? There's a reaction occurring, an endothermic reaction that is sucking energy from the surroundings. Glow sticks. Glow sticks are chemical reactions. You take the glow stick and you bend it to break the little glass tube inside, and as those two substances mix, a chemical reaction occurs and light is given off. So heat can be absorbed or emitted. Light may be emitted. That's evidence of a chemical reaction. Those forms of evidence can fool us, though. If you put a pot of water on the stove and heat it up, a gas forms, right? You may say, oh, look, chemical reaction, a gas is forming. But there is no chemical reaction. We're just changing the state of the water. The water is going from a liquid state into the gas state. If we could look at the individual molecules, we'd see that all the particles are staying the same. We are not making a new substance. We are just transforming the state of an existing substance. So water boils, gas is formed, but no chemical reaction has occurred. Chemical reactions can also occur without anything that we can detect just with our senses. That can happen as well. So it's not foolproof, but it's a good it's all we've got, really. So Which of these changes involve a chemical reaction? And then the dreaded explain. Explain your answer. So butane burning in a butane lighter, is that a chemical change, a chemical reaction? Yes. Why do you know that? Because it makes light and it makes heat, right? So this is a chemical reaction, and we know that because it gives off light and heat. I'm not going to write the answers out. What about butane evaporating out of a butane lighter? No. So this word evaporating is our big clue there. Evaporation is a term that describes a change in state. Anytime you just have a state change, it is not a chemical reaction. Wood burning. Yeah. Why? How do you know? So it emits carbon. Emits carbon dioxide and water. That's not something that you can directly observe. But do we see? It does give off light and heat. And then what about what's left after the wood burns? Ashes, right? So the wood has changed color, and it's obvious that the amount of matter left there has decreased, right? So we see a lot of different changes when wood burns. How about dry ice subliming? No. This is not a chemical reaction. Again, subliming is a description of a physical change. It's one you might not have, heard about. We mentioned it in an earlier chapter. But sublimation is going directly from a solid to a gas without melting in between. Any questions?